Alright, so we're asked to simplify the following rational expressions. Now, how do we simplify this expression? Well, the first thing is that we have to understand what they mean by simplifying rational expressions. Remember, as an example, I'll give you something a little bit simple. Let's call this an example. And we have, say, 8 over 12. And I want to simplify this expression. Well, usually the way that we do it is that we take a look at what number goes into 8 and 12, and we divide by that number and we simplify the fraction. But let's take a look at it in a different way. What two numbers multiply to 8? Well, in other words, what are two factors of 8? But we know that 2 times 4 is 8. Now, factors of 12. Well, we know that 3 times 4 is 12. And you notice that just by factoring these two numbers, I just find that I can actually divide these two 4's here because they're being divided and there's a multiplication symbol between these two terms, so I'm allowed to divide these two terms separately. So I divide 4 into 4 and that gives me 1. So then at the end I'm left with 2 times 1, which is 2, and 3 stays on the denominator. So now I have 2/3. I just reduced this rational expression and it became 2/3. So now we're going to take a look at this rational expression and try to do the same thing. So we're going to try to use the same idea, but remember that factoring a regular number, an integer, is different than factoring a trinomial. I mean, they look different. So for instance, let's try to factor this trinomial. To factor a trinomial, remember that they're a product of two binomials. So I'm going to have to use this parentheses. Now I want to know what two numbers multiply to x squared. So I know that x times x is x squared. Now I need two numbers that multiply to 15. Well, I know that 3 times 5 is 15. Now the problem will be, what should their signs be? Well, to do that, again, we're going to take a look at the product of the inner terms. So 3 times x is 3x. X times 5 is 5x. And somehow we want to get that negative 2x here that we have in the middle. So to get to negative 2, we know that we have to subtract these two numbers. Now, if we're subtracting, that means that the signs must be different. So what should the signs be? Well, we know that if we have to subtract two numbers, the signs of the two numbers must be different. So that means that one of them is negative and the other is positive. But remember that we want the middle term to be negative. So the sign of the largest number has to be negative. So that means that 5 is negative, 3 is positive. So then therefore this is a positive 3, and because the 5 came from this 5, that's the negative 5. So we just factor the numerator. And you notice that a positive 3 times the negative 5 gives you a negative 15. And by doing the inner and the outer, we get somehow the middle number here. Now, be aware that this method could be done a little different. Just because there's no coefficient in front of the x squared, we're allowed to actually just figure out what the product of the numbers, what two numbers multiply to 15 and add up or subtract to 2. That's another way that you can view it. But remember that if this number is a different coefficient, say 2, 3, it changes the whole game. So that's why I usually like to do it using that method of inner and the outer. So that way we only have one method for every problem instead of having two different methods. So now let's take a look at this trinomial. Now you notice that there's no GCF, there's no common factor here at all. So what we're going to do is we're going to try to go straight into trinomial factoring. And again, we need the parentheses. So we want to know what two numbers will multiply to a 5x squared. Well, the two numbers 5x times x, that gives us 5x squared. Now we need two terms that multiply to 10. Well, we know that 2 times 5 is 10. So let's try 2 times 5. Now notice that if you put a 5 here, it wouldn't really make much sense because then that means that they have a common factor. So you don't want to write a 5 where there's already a 5, because otherwise then that means that there was a GCF here, or common factors. You don't want to do that. But in any case, you can try it and see if it works. If it doesn't work, it's fine. You can just try the other method. You try to switch the numbers around whenever the problem doesn't work. So now we have 2 on the first parentheses, 5 on the second. Now we want to see if we can get the middle term here, that negative 23x. Well, we multiply the inner terms together, that gives us a 2x. We multiply the outer terms together, that gives us a 25x. Somehow we want to get that negative 23. So again, we'll take a look at the 2 and the 25, and to get 23, we know that these numbers have to be subtracted to get to 23. So that means that the signs must be different. Now the question will be, where does the positive go and where does the negative go? Well, yeah, the sign of the largest number has to be negative for us to get that negative 23. So that means that this should be a negative 25, and therefore the 2 is positive. So we have the 2 being positive because that 2 came from here, and the 25 came from this 5 and that 5. This is the one that is missing the sign, so this 5 must be negative. So we just finished factoring this trinomial. But now if you take a look at it, we have this trinomial that turned into a product of 2 binomials, and this other trinomial into a product of 2 binomials. And we notice that this is a product again, just like the example we had before, where we had a product and a product on the denominator, and because these 2 terms were exactly the same, they divided into each other and gave you 1. So the same idea happens here. We have x minus 5 being divided into x minus 5. Well, that into that is 1. They're exactly the same terms, they're dividing into each other. At the end of the whole problem, we end up having just x plus 3, because x plus 3 times 1 is x plus 3, over 5x plus 2. So this is our final answer after simplifying the rational expression.